Hi everyone, thanks for coming back. Today I'm going to talk about one of three pieces of sort of what's emerging as efforts I think are important to sort of really think about how we remake the industry. And this is not, when I say we, this is the industry itself, not a specific subgroup of it. There's three topics that I'll touch on. The first one I'm really touching on today is this Daaad, which is an explanation of how mapping an entity component system that we're stealing, that think about stealing from the game world, would actually allow us to solve some of our data interop problems, or interchange problems is the way I would like to think about it. The future ones will touch on sort of why the industry might not be happy with the current state of tools, and the third one will be around thinking through a roadmap for firms wanting to change their structure, and what that means is, like, if we can do the first two, then you can start to implement new kinds of roles that help you sort of change the way the firm works, but that's a more nuanced thing. But today I'm going to just cover Daaad, which is the way I'm phrasing this, and where this silly acronym comes from is disaggregating applications and aggregate data. And really just this comes from the notion that today the single source of truth is inside an application where we export copies of that data, and there's a really powerful way of solving this problem that can aggregate it externally and gets more benefit than aggregate it internally, because you get sort of the benefits of bringing it all together. So the problems this is really trying to solve, and we'll get into the details here, are collaboration, multi-role. I'm going to use furniture as an example, and when I say multi-role there, it's maybe it's the same kind of person: interior designer, furniture buyer, procurement individuals. Maybe they have very similar roles. There's no, in certain places there are electrical roles for workplace furniture and stuff like that, but the idea that there's actually a bunch of different work to be done with furniture, and the idea that we need to think about how do you make workflow and tools that support that. And that's where you get into the next step, which is multiple tools, so a clear path for more concise solutions, and how do you integrate, sort of new solutions with existing ones. A really key aspect is how do you support multiple simultaneous use cases, and this is an important thing that we don't do well at all today without a tremendous amount of effort. So practically, some of the things you're looking to solve with this is sort of solve simultaneous model authoring things and make computational workflows first class. And this is not the main reason to do this, but it's a benefit, because if you work this way and you think about the data sets as being more finite than they are today, it's much more logical to think about how you can make computational solutions that work on top of that data. So if you followed along or saw any of my previous efforts, I've talked about this sort of problem where we are basically taking data, creating it, doing a tremendous amount of work, and throwing it down a hole, if you will, that is another application's sort of representation. It's a tremendous amount of work. It doesn't scale well, because the bigger projects get, the more work it is to get the data out. And sort of basically said this sort of representation where you sort of bridge the data out into what I've not maybe said, but sort of said is something like USD, which is a universal seam description from the entertainment space, but that's really not the best way to think about that. And so one of the things I've spent time on is how to explain how to do this so we actually solve more than just, it should be open, because that's not really the best sort of best outcome, because it just simply means that we have to pick a winner when it comes to data representation, and then we're having tens of open representations versus closed representations discussion versus how do you make multiple data sets work together. So I'm going to talk through furniture because one of the things that you're seeing in the market is there are starting to be several tools that say, actually, this is a space that the user experience could be vastly better than using a generic tool. But the question would be, how do you make these better experiences, simplified user experiences for a certain task? How do you work with those within the sort of larger market? And I'm just showing two examples that are sort of on the market. I won't reference them by name, but I've sort of, for my demo today, I've invented the most simple and valuable furniture layout software someone can make, which is basically to say it's trying to be a super simple application that does one or two things well, helps you plan simple layouts, let's say. So the first thing I do is, okay, there we've placed our furniture. It's a very generic representation. Maybe it's a lounge. I've used a sort of known type of furniture, but we know very little about this information because it's only trying to solve a small portion of this problem. So if I back this out, today what we do is maybe, okay, well, I can't do everything here, so I have to move it to a more robust generalist tool. So the way you typically conceptualize this today is I've exported 9, I think there's 9 whole chairs, and then I've imported and created them from that data here. So conceptually, one of two things has just happened. This tool became invalid because you've had to replace it with this representation because, sort of conceptually, you really only want one source of truth, right? You don't want two. But there's often plenty of times in the design process that you want the benefits of multiple tools. So the downside of that is now you just have 2 copies of the data and you have to brute force your way of coordinating between these two, which is, sort of neither one of these workflows are the right or a great scenario. So what if we could think about this a little bit differently? And so instead of thinking about this being 9 whole chairs, we said, well, actually, really what I did at this point is made an entity, and those happen to be chairs, and there's 9 of them. And that's to say this is just like the concept of a chair in this mapping and stealing from the entity component system model. This is just an entity. So now I have roughly 9 identifiers that know they're chairs. If you think about it, just unique IDs that say chair, I'm 9. And if you break those down into the things that this tool might provide, you get things like style, which is sort of like could be seen as a named concept like lounge chair. And you might got the locations. That could be just XYZ positions, and you get some geometry. So I'm showing the geometry is dashed is maybe I already know that this really isn't the geometry I want to use for most of my workflows, and maybe I want to use what's coming from the next tool. So let's say I move this data into a next tool. So instead of importing it, the first step in a workflow that I'm describing is you reference it. So now I have access to all the data. I have access to everything else that was developed in the first solution. So I know the style, I know the location, and I know the geometry representation that came with it. But let's say I want to add to this. So today where you do an import and take quote-unquote ownership of the thing, here what you're really doing is doing a copy, create, and map. Copy being just straight up copy the geometry into your tool, and if you can use the same representation, you've made the link, and now you have a copy that you can make additional edits to. Create being if I need to convert it into an internal geometric representation. I need the first class, if you will, kernel representation. Or map would be, well, the simplest one in a sort of, if you're familiar with a Revit Rhino workflow, is maybe the block in Rhino that maps to the family in Revit. So either way, what you've done is you've maintained the reference. You're not removing the reference. That's a key aspect. You've made a link to it and made a new representation. and then you go through and add some new data. So where this differs from a previous approach is, instead of thinking about the second application taking ownership, what you've done is saying, well, actually, I got this bit of definition that came from one application, a little bit more that came from another, so I got some new geometry. Now I can say, okay, I want to supersede that. I got some new locations, but I can have some two sets of locations. I'm still going to use that. I got some additional stuff like product type, properties, and materials. And now what I have is the assembled representation from across two tools. And now what I can do is actually decide which one of those represent these are called components in this place, but you can think of as traits or something like that. You get the opportunity to say, well, I want to make an assembled representation that pulls from the things that I care about that came across different tools. So the neat trick here is, instead of throwing away the ones that came before, you're just making an additive process and then applying a filter, if you will, to say the things that make the chairs in this example look like this. And the nice thing about this idea is it's extensible downstream. So let's say I've sort of, this is the design team side. They've made a decision about this is chairness, if you will. And I can share with the CM, let's say, properties, location, and geometry. Maybe that's the only thing I want to share because these other things like material aren't relevant to them. It's not the right time in the project to do so. You can always update, and we'll talk through that in the future. And they could have something like a furniture procurement app. Oh, we need to buy these things. It goes in and adds new components, like maybe the actual product, the cost, and procurement. So what you've allowed for is these chairs to exist simultaneously. This is a key aspect of what we talked about previously. And there's now 3 active products that are defining this set of chairs. But they're not replacing one another, they're just additive. So what is very different from the world today is, like, if I did this and there were any updates, unless the application specifically did something, these things would have to be replaced and lost. Versus, well, no, as we'll see if I come back in a second, I can do that. And another key point here is, well, this could be an application, but this also could be an algorithm that sits right here in the computational thing. Like, okay, every time I see a certain style of or set of properties on a chair, add an associated cost to that. So it could, this algorithm could own cost, this application could own products in the procurement process, and you've sort of just made a constellation of applications plus algorithms work together in such a way that you could associate one of these components with an algorithm and really stitch these things together. So if I take a step back, let's say I need to sort of make changes in the locations in my planning app, which in this world you really want to be able to do. Like, I want to make this the owner of a certain subset of the data for furniture. So what you're able to say now is, actually what I'm going to do is going to do an update. But I'm not updating everything. I'm just updating locations, which that progresses, and actually what you get is a version 2 of the locations coming from this app. So nothing else has changed. You haven't overwritten anything. Certainly you could change other pieces of information. And you could even say that, well, actually in this phase of a project, I'm going to overwrite properties. And that's an sort of should be seen as a workflow specific set of decisions. The key thing, though, is in a model like this, you never want to overwrite. You want to just make a new copy, a new version. So those properties that existed from the second application would still exist, but you'd have a new set if you wanted to replace them. And that's like, if you play this forward, You can see we have locations 2. When those come in, what we want to do is actually transmit those to sort of the procurement team. Everything else can remain the same. Those locations are still a reference, but let's say in the sort of course of the work, there's a reason to update these. The room names change because the owner has something, because there could be a sort of an owner component of this discussion as well. So you get version 3 of locations, which actually becomes owned by the contractor. It doesn't supersede anything else, but this concept of selective ownership translating during a project is pretty key as well. So breaking down the definition of things into their individual components is the technical term, but traits like location is different from a set of properties, it's different from the geometry, is different than materials. You can imagine how in this model LOD could be addressed for geometry, because you could have the geometry that's shared, and then here's the geometry I need to represent it for construction or for operations. So there's a ton not shown here, and this is trying to be intentionally simple, that switching from a complete ownership model to this entity and component model where the traits, the individual sub aspects of something can be broken together and assembled externally. That's the key piece of information I want to talk about today. The structures to manage, collect, and organize these things are very much an important part, and that's really what you might say there's a key things to learn from USD in. There's other things that are way too complex for us to want to take in, but we need to address those. Those aren't done here. I'm not showing things like the relationships between the spaces. I'm not showing things like duplicate layouts, etc. This is really trying to say, today, if I have 2 applications, I really have to either live with duplicate copies and sort of manually have to decide which one, or duplicate copies and manually coordinate them so they're up to date when I get to the final state, or I have to get rid of an application in part of my workflow because it's no longer valid, and this is functionally the thing we need to think about. The other thing that isn't there is, I'll just step back here, not all of these things need to be the same application. Like the idea that we would have a schema that covers everything here, like within Building Smart we have IFC. It's got properties for cost, but cost is a pretty complex animal, or materials are a pretty complex animal. If you think about this approach allows you to say, well, I can have a really robust, maybe let the visualization people handle one piece of the material, what it looks like. And you can have another sub-component of materials that, like, its life cycle cost. Those are 2 different components. I'm just showing this in a simplified way, but what this model allows you to do is keep subdividing by relevant data. It could be that on a project, a small one, that everything is, everything can be bundled up in materials, like just one component. Or it could be that you actually need to break it down in 3 or 4 additional pieces. But this is a fundamental aspect of, and a benefit of this sort of approach of being able to assemble the data externally. So I'm not going to talk about part 2, tools to make tools, but I hope this sort of thinking about how we can do 2 things: externalize the data into a common format, and it's a little nuanced, but that common format doesn't mean that it all has to be the same schema. It can just be a way of stitching the data together so it's useful for different tools and workflows, and how that really is a departure from what we have to do today, which is give ownership to the applications, and in this workflow we can assemble them externally, which I think to me is the most powerful part of breaking down into objects, because then you can think about sub-object pieces which allows you to do such a thing. So part 2 will come, tools to make tools. That's it for today. Thanks.